Hey everyone, welcome to my talk on enhancing data refinement with polars. Today we dive into how polars leverage SQL and Python for efficient data manipulation. I hope you all enjoy this talk, and let's start. So our agenda for today is first we're gonna answer the question why polars. We're gonna do introduction to SQL context in polars. We're gonna learn how to utilize lazyframes for big data sets using SQL context in polars. We're going to learn about common table expressions, which is a nice feature polars has with SQL context. Okay, so why polars? I think first we need to answer the question what polars is. So polars is a data frame interface on top of an online analytical processing query engine. It's implemented in Rust using Apache Arrow as the memory model. Now, why should you choose polars when you have so many options out there? So first we have high performance. Polars is designed for speed. It's leveraging Rust efficiency and safety to perform data operations fast. You can visit this link in order to see detailed polars benchmark against other known libraries such as pandas. We have memory efficiency. Since polars is written in Rust, it uses an enhanced memory management without having garbage collector. We have I/O. Polars support all common data storage layers such as local and cloud storage. We have lazy evaluation. We're going to go into this more deeply in this talk, but in short, polars offers lazyframe that allows for lazy evaluation to reduce memory usage. We have easy to use API. Despite its high performance, polars provides an user-friendly API, making data manipulation and analysis straightforward for Python users, especially for those coming from other data processing libraries. We have SQL context, which is our subject for today. And we have versatile data manipulation. Polars supports wide range of operation, include filtering, sorting, joining, grouping, aggregating data. We have interoperability. So polars can interact easily with other Python data science tools and libraries, again, such as pandas. It's allowing for seamless integration into existing data science workflows. And we have open source, so polars is an open source project right now, and according to the owners, it will always be an open source project. It is driven by an active community of developers, and everyone is encouraged to add new features and contribute to the project. You can visit the official user guide with this link. If you need more details about polars, I highly recommend it. Okay, so let's start with introduction to SQL context. We're going to go hands-on right away. So we have this block of code. First, we are importing polars. Then we're creating a new instance of SQL context. So that's the syntax of doing that. And then we're creating a small data frame. Here we have a small data frame with 3 columns, ID, name, and badges. ID is 1 to 3. We have Charlie, Bob, and Addis, and each one has a certain badges, 1, 5, and 8. Then we are registering a new table in our SQL context. So the syntax for doing that is register. Our first argument is the table name, so it's going to be trainers. And our second argument is either a data frame or a lazy frame. Now we're using a data frame. And then we are executing an SQL query over our SQL context. So we are using select ID name from trainers where badges equal 8. So a simple SQL query that will fetch us all the ID and names from our trainers dataset that has 8 badges. Here we are using the argument eager equal true. Eager basically means that polars will return a data frame as the result and not lazy frame, which is the default. In case our result is small and can fit our memory, we can use eager equal true. And then we are printing the result. So let's look at our result here. So we have a small data set with a columns ID name. ID is an integer and name is in a string. And we have Alice, which is the only one that match our query because she has 8 badges. So that's SQL context in polars. Now let's go over lazyframe. So what are lazyframes? Lazyframes in polars are a clever approach to data analysis, allowing the entire query to be reviewed before execution. This method not only enables better efficiency and optimization, but also supports working with datasets larger than your machine memory by using streaming. This means Polars can process huge amounts of data very smoothly on almost every machine. So let's go a bit hands-on on how to use Polars, lazyframes with SQL context. So first, we have two datasets. One is Pokemons, and the other one is trainers. So as you can see, Pokemons is a very big dataset. It has 200 million rows with 4 columns, ID, name, type, and trainer. And we have another dataset called trainers, which contains 3 columns, ID, name, and badges. So Pokemons cannot fit in memory in a lot of machines. So here we want to utilize lazyframes in order to query over this big dataset. So let's go a bit hands-on and see how we can do that with Polars. So first we have the scan CSV. Scan CSV, when you're using it, it scans a file, and rather than reading the entire CSV into memory, Polars create a lazyframe with reference to the file data. So no processing of the data happens until you explicitly execute a query over it. Here we're using the infer schema length argument. Infer schema length makes our life easier. And if we don't know the schema of our dataset, Polars basically scans the amount of rows it takes as argument and set the schema itself. So with bigger number, usually inferring the schema will be slower. So we were reading 100 rows in order to understand our schema. And as you can see, we have another scan CSV for our trainers. Here we are not using infer schema length, but we are telling Polars what the schema of our CSV is. So we are telling ID is an integer, name is string, and badges is also an integer. Then we're creating a new SQL context, same way as we did before. Now we are using register many. So register many allows us to register more than one table at a time. So now we are registering 2 tables. One is Pokemons, which pointing to our Pokemon's lazyframe, and the other one is trainers. And now we're printing our schema in order to see what our result will be. And we're executing a very simple SQL query called show tables. Now we are also using eager2 because we want a data frame as the result. So let's see the result. First, our schema prints give us 2 ordered dicks. As you can see, Polars infer the schema pretty well. ID is integer, name is string, type is also string, and trainer is also string. So Polars doing a very good job with inferring the schema itself. And of course, trainer has the schema we configured. Then let's see what show tables will give us. And here we have a very small data frame with only one column name. And we have Pokemons and trainers as our tables. So far, so good. Now let's see how can we run SQL queries over our 2 new tables. So here we are using our SQL context that contains 2 tables, Pokemons and trainers. We are running a simple SQL query, select ID trainer from Pokemons, where Pokemon's name is Charizard. Why? Because everyone loves Charizard. And we're using sync CSV with one argument called result.csv. So since we are not using eager equal to like we used before, the result of our query is going to be a lazy frame. So in order to dump it, we are using sync CSV, which is evaluating the query in streaming mode and write it to a new CSV file. So here we are dumping all the result of this query into result.csv. Now let's look at the result. So that's how result.csv look like. We have the IDs of the Pokemons that are Charizards, and we have the trainer that the Charizard is belong to. Okay, now that we went over a very simple SQL query, let's go over common table expressions, or CTE. So common table expressions are a feature of SQL that allows you to define a temporary named result set that can be referenced within an SQL statement. STEs provide a way to break down complex SQL queries into smaller, more manageable pieces, making them easier to read, write, or maintain. So let's look at an example of a CTE. So as you can see, the query is a bit more complex. So we're using with as the keyword in order to create a common table expression. We're gonna call our new our new temporary set champions, and it's gonna contain all the trainer names and trainer badges from our trainer dataset that has 8 badges. So it's gonna give us all our trainers that has 8 badges, and after we get a result. By the way, we call it champions because if you ever played a Pokemon game, you know that in order to complete the game and entering the league, you have to get 8 badges. So after we have our champions, we're gonna select our trainer from our Pokemon dataset. Here we're using an alias called trainer name, and we are also gonna select all the Pokemons of this specific trainer. So that's why we're using join here. We're gonna join on the champion's name, which is the trainer name, and on our Pokemon's trainer. And we're also using limit, which is another nice feature that Polar has. It supports limit and order by. So we're gonna get our 6 Pokemons of every champions that exist in our trainers datasets. Now here we're using collect. Collect is another way of getting our data from a query result. We're using stream equal to because we don't want to collect all the results into our memory in case it's a very large result. So we're using streaming. Streaming basically returns a generator. Then we're using toDix in order to convert the result row into a dictionary. Now let's see our result and how it's looking like. So we have 6 results because our limit was 6, and we only have one champion called Alex Bell, and our Pokemon name in each in the first 6 results. So as you can see, the alias also affected the dictionary. That's CTEs. A quick disclaimer. Please note that Polars do not support all SQL operation. If you need more information about which SQL operations are supported, you can go over the user guide. There's a very nice list there that tells you all the operations that are currently supported. So that's CTEs, and that concludes our talk. So thank you very much. What we learned today, Polar's SQL Codex offers a very unique and powerful tool for data manipulation. It's combining familiarity with SQL with the performance of Rust-powered operations in Apache Arrow. Whatever you are a seasoned data professional or very new to the field, I encourage you to explore this library and experience the efficiency gains firsthand, both for small and large data sets. Thank you for your attention. I look forward to any questions you might have. You can mail me at tomlevy02@gmail.com. I look forward to any question and enjoy the rest of PyConf42.